93 BC 45, we have if f of x is the sequence from 1 to infinity of sine square of x to the k, then f of 1 would be what? Well, a couple of things that you should notice here. One is that this is a geometric series. And how do we identify this as a geometric series? Well, the most basic of all geometric series would look like the sum from n equals 1 to infinity of x to the nth power. And so the first term would be x to the first, second would be x to the second, x to the third, etc., x to the fourth. How we get from one term to the next is by multiplying the previous term by x. And when we have that common multiple, which is called a common ratio in geometric series, then we have, obviously we have a geometric series there. So you can see in the series in question here that if f of x, we'll write out the first few terms of that, you start when k is equal to 1 and you get sine square of x. The second term is sine square of x to the second plus sine square of x to the third, and so forth and so on. Well, you can see here the same thing is true. How do we get from one term to the next? We're multiplying by sine square of x. Multiplying by sine square of x. Since we have a common ratio, therefore we have a geometric series. And when we have a geometric series, then we do know that it converges when the common ratio is less than 1. Now, we're not asked for that here. The common ratio is sine square of x, and sine square of x is going to be less than 1 whenever sine of x is not equal to sine square of x is not equal to 1 or negative 1. And so those would be at pi over 2, 3 pi over 2, and any multiples of pi over 2 and 3 pi over 2. But we're looking for f of 1 here, so that's really not an issue. And there are no answer choices that say does not converge, so we don't really have to go down that path at this point. However, we do know that a geometric series, when it does converge, in this case for x equals 1, it will converge, will be the limit as n approaches infinity of the nth partial sum is a over 1 minus r. Now in this case the first term is sine square of x, and 1 minus r is also sine square of x. And some people might recognize that this is, the denominator anyway, is another way of writing cosine square of x. And so this whole thing comes out to just be tangent square of x. To find f of 1, it would just be tangent square of 1, and we can use our graphing calculator to find that. Make sure you're in radian mode, and the answer is going to be 2.426, rounded to 3 decimal places. So hopefully that makes sense there. Again, the interval of convergence is not really a question here, but you could think about that and see that at 1 we're not in danger of not converging. All right, that'll do it for this problem then.